Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will start with a new component, that is time series modeling. In the last couple of lectures, we have discussed various types of econometric modeling, starting with simple regression modeling, multiple regression modeling, again the cluster between linear regression modeling and nonlinear regression modeling, again the kind of modeling where dependent variable will be qualitative in nature, again independent variable will be qualitative in nature, and we have gone through various test structures, starting with specification test, goodness of fit test, diagnostics tests, and that to check the validity of the estimated model. And then over the time we have used several kind of examples, and then we use different kinds of model to apply the engineering econometrics tools to solve some of the engineering problems, and as per the kind of engineering requirement or the kind of organizational requirement and the kind of industrial requirement. However, the thing is that whatever we have discussed till now, mostly it is the kind of cross sectional modeling, where we have used cross sectional data to estimate the model and use the model for the kind of prediction and the kind of forecasting. That means, any kind of engineering predictions and any kind of engineering forecasting. So, the cross sectional data may be like individual specific, organizational specific, then sectoral specific, country specific, then kind of institutional specific. So, likewise we can have various forms of cross sectional data. So, that means basically it brings different kind of setups, and through which you can actually generate the data, and with the basis of theory, problems and the kind of requirement, we like to you like to use this data and pick up a kind of econometric model, and then we estimate, and after doing the estimations we can go for the testing, and then once we get the clearance from the testing through like specification test, goodness fit test, then the diagnostic test, then we will go for the kind of engineering forecasting requirement or the engineering prediction requirement. So, what is happening here, means in this kind of time series modeling, one of the most important is the data structure. So, obviously the model itself will give you the indication what is the kind of data we have used for the estimation process and the kind of prediction process. The modeling structure will be in three different forms. So, starting with cross sectional modeling, then time series modeling, and again the kind of panel data modeling. So, these modelings are exclusively on the basis of data structure. If the data, I mean say if we use time series data for a kind of estimation process, then we simply call as time series modeling, and when we use cross sectional type of data, then we call as time series modeling, and then when we pull both cross sectional and time, then it will come as a pool data, and later we will have a discussion on the kind of concept called as panel data, and that too panel data modeling. So, whatever we have discussed earlier, that is mostly with respect to cross sectional modeling, and right now we will discuss the time series modeling, and after knowing the time series structure and time series modeling, we will move to panel data modeling. So, let us see what is the kind of time series structure and the kind of time series modeling, and what are the kind of problems through which we can actually use time series modeling to predict the a kind of engineering requirement or something like a kind of production requirement or something like that. So, let us see how is this structure, and first structure is the understanding of the time series structure. So, in this particular unit we like to understand first time series data, and then we like to go through various time series model, and then starting with the like moving average modeling, autoregressive modeling, then ARIMA clusters, volatility modeling and VAR modeling. So, we have lots of kind of components through which we need actually understanding, and we need actually kind of clarity to apply some of the engineering problems, and that can be solved through these models. So, basically understanding these models are very important, because all these engineering problems may not be fitted, because these particular models are exclusively used for any kind of engineering forecasting. So, provided the data structure must be time series in character. So, that is how the first requirement of this modeling is to understand the data structure. Once you understand the data structure, then we can go for the modeling, right. So, what will it do here? We first know what is exactly the time series. So, time series means the data will be available mostly over the time. For instance, we will have like this, we can have like this, let us say y is a variables, and we will have a time specification like this, and this is a variable, and this may be a kind of information, let us say production of a industry. Then we like to know what is the production of that industry over the time. So, it may be annually, it may be monthly, it may be weekly, it may be kind of day wise. So, the T will vary like this 1, 2, 3, 4 and so on. Then again there will be production unit like this. So, that means there is a need of consistency. If it is the annual data, then the starting and ending must be clear. For instance, let us say the production data of a industry since 1991 to 2001 or 2018. So, you will get annual data, and that itself gives gives some kind of consistency, and so means the data structure itself gives you similar kind of structure through which you can do the trend analysis, then the kind of prediction. So, compared to cross sectional data, time series data has a more structure, because it maintains consistency, while cross sectional data there is no such consistency. So, all the industry can be move here and there, but in the time series data, data must be in a chronological orders. If it is monthly, then starting of the month and ending of the month, starting of the week, ending of the week, starting of the day, ending of the day, starting of the year, ending of the year. So, these are all very essential, and the data structure must be fitted on that angle only. Then it clarifies the structure of the time series data. Otherwise, the beauty of time series will simply actually lose its importance. So, what we can do? So, we first know what is exactly this time series structure, then we will go through different components and different models which is connected to time series data, and then the kind of engineering problems. So, any engineering problems, and when we actually exactly identify the problem and the kind of variable structure, so we like to see whether the data can be available in a time series format. If the data will be available in time series format, then by default we can use time series modeling to predict that engineering requirement and the kind of industry requirement. So, let us see how is this particular structures, and ultimately to know these ones we must actually see the time series structure. So, this is what actually representation of time series we can define in different way, but what we have already actually highlighted, it is like a time series is a set of observation taken at specified times, usually at equal intervals. For instance, we can define in other way. Time series may be defined as a collection of reading belonging to different time periods of some economic or composite variables or some kind of engineering variables. And basically time series establish relationship between cause and effects. There is a high chance that the information of a particular time period will be closely linked to the previous time periods, and again it may be closely linked to the post time period. So, that is why there is a slightly cause and effect relationship within the data structure, and that is what the you can say the beauty of the time series structure. So, let us see how is this time series data altogether. So, now if you look here in this table, and here there is day wise informations, and then over the day. So, we have actually packets of milk salt. So, starting with Monday, Tuesday, then Wednesday, then we have here Thursday, Friday, Saturday and Sunday. So, this is actually just 7 days data structures, and by default starting with Monday to Sunday. So, that itself maintains some kind of consistency. So, that means one way you can say that there is some cause and effect relationship. For instance, if you start with let us say Thursday data, you see here at 75, then we expect that this 75 structure has a connection with previous data structure, say let us say 85 or somehow 88 or 90, either exactly that two with 85 or with the help of all these three. Again the 72 item may be connected with 75. So, that means there is some link actually. Of course, it is not a kind of increasing order or a kind of decreasing orders. So, here some ups and downs happening, and it is not the ups and downs because of the day wise impact. It may happen that there are some other factors. As a result, the data structure is changing. For instance, packets of milk sold day wise. Of course, the next day a selling obviously depends upon the previous selling, but ultimately if something going wrong in the market or due to some external forces like the weather is not so good, or there is some kind of crisis or some kind of something external attacks or something like that, then by default it will affect the market and then it will affect the selling process. So, this is how the first structure is the day wise information, and that itself gives the indication about the time series data. And similarly, this is the yearly data, that to decadal data starting with the 1921, 1931, that is with respect to population. So, that means it is also a time series data where the particular interval is on the basis of 10. So, when we will start with let us say 1921, 1922, 1923, then the interval will be in between 1 only, but here we have the interval 10. So, that itself also justifies the time series structure. It is not that 1 day interval, it may be in between means we need actually what we can call as a balance gap. If it is actually in between balance gap, a balance interval, then that itself will represent the time series structures, and as a result we can actually use time series modeling to predict as per the particular engineering requirement. So, far as the importance of time series modeling is concerned, so we have actually means multiple use. That means this itself is a multidimensional character, and mostly we can having the time series data, an engineer can predict about the changes in the engineering, or an economist can predict the business environment, something like that. So, that means some of the problems connecting to time series modeling will be like this: engineering forecasting, revenue forecasting, safety forecasting, utility forecasting, then sales forecasting, stock market forecasting, quality control forecasting, inventory studies, economic forecasting, and then budgetary analysis, risk analysis. So, that means multiple areas where we can frequently use this time series data to do the predictions and as per the particular engineering requirement. So, that means briefly I have just highlighted some of the areas where time series moldings are very frequent, because these areas the information availability or what we can call as data are actually in a time series format. So, when a particular problem is having data in a time series format, then there is a high chance that time series modeling can be applied. Of course, that particular problems needs that requirement on. If that problem not required at all for the kind of time series modeling, then you can skip, but there is a high chance if the particular variable information is in a time series format, then you can easily apply the time series data, and if not, then you can again through cross sectional and time series you can use the panel data. But time series has unique kind of identity and unique kind of structuring through which you can you do the modeling. So, that means with a particular variable we can create a multiple variables by introducing the log variables, which is that is means beauty of this time series structure. So, that means if you have a variable say y t, you can create y t minus 1, y t minus 2, just same data, it will be copied and pasted one point behind, then you create data structure with respect to y t minus 1 and y t minus 2. So, that means that is the process which you can actually create with the help of only time series data. Otherwise, you cannot just copy paste and create log variable like t minus 1 and t minus 2. If the data maintains consistency, then you can create a log variable. If the data does not maintain consistency, so you cannot create a time series variables or or the kind of log variable, and that too the use of time series modeling. In the case of time series modeling, so we have actually understanding of the data which we have already discussed in details, and basically in the time series we have specific components. The first component will be secular trend, that means the process how the data is structured or maintain the consistency. Then there is a seasonal variation, cyclical variations and irregular variations. So, that means since it is actually recorded and collected over the times, maybe with annually or with a kind of day wise or week wise or monthly and then quarterly, but it has a kind of pattern, and when we have the data, so that particular pattern may be secular in nature and seasonal in nature, cyclical in nature and irregular in nature. So, that means there is a variations, means when move from one point to another point. So, there is a variation. If there is no variation, then by default we cannot use this data for any kind of modeling, that to engineering econometrics. So, obviously, the data will have some kind of variation. Now, the issue is in the time series data, when there is a variations, that variation may be lead to secular trend, may be seasonal variations, may be cyclical variations and may be irregular variations. So, we will see how is the kind of structure, and then we will discuss as per the particular requirement. The first one is the understanding of the secular trend. If you will say that time series data follows a secular trend, so what is exactly that? So, that means it is the increase and decrease in the movements of time series, and that is what the term is called as secular trends. A time series data may show upward trend or downward trend for a period of years, and this may be due to multiple factors, like may be due to population increase, may be due to technological advancement, or due to large shift of consumers demand, or something like high growth rate of industrial base, or the kind of money market. That means money flow of money supply itself will generate some kind of So, there is lots of interdependency and connections through which the time series data have ups and downs. If there is no ups and downs, then by default what we have already said, that this particular information or this particular data cannot be used for modeling. So, we need some variations, but ultimately we like to know how these variations happening. For example, a population increases over a period of time, then by default price increase over a period of years, production of goods on a capital market of country increases. So, that means if something happens, then the other things by default will happen. So, that is how we are actually very much interested to know the kind of trend structure and how it happens actually. Obviously, when there is a kind of trend, some factor may be responsible for that. That is how it brings a kind of trend. If that is not happening, then it may be kind of more or less same. For instance, if there is no change of populations or there is no change of income and there is no technological advancement. So, whatever demand in the market, so that will be remain there. Okay. So, by default, so there will be no change. So, it will be simply kind of stagnant. So, if there is stagnant and the variation of data is almost all 0, then that means technically we are not in a position to do the modeling. And in reality that cannot happen, even if technological progress or population change. So, these are all actually long term impact, but still in the short run there may be some kind of change, and that may not be very large one, in a small interval, but obviously. So, you will find some variation will be happening. You go to any market in the world or any engineering area. So, whatever informations are recorded for a particular variable, most of the instances there is a kind of variations, and also there are instances where the information base is more or less constant. For instance, suppose there is a kind of engineering experiment, and the means very specifically let us say it is a kind of production process, and the entire production process is going through a kind of machinery process only. So, now if the machine is okay and everything is okay, then obviously the production quantity may be same over the time, but after a particular point of time it may not actually true. The thing is that machine itself has a some kind of depreciation. So, when machine becomes old and old, by default the particular production capacity may not maintain. So, there is some kind of deviations. So, that means up to a particular point of time there may be the data structure or production structure may be stagnant, but after a particular point of time and definitely there will be variations. That means technically in some instances the change may be takes time, and sometimes the change may take actually very less time. So, but there will be definitely ups and downs, because nobody can maintain a particular stagnant of in a kind of infinite framework. So, it will be definitely have a change. So, means in the real life scenario you talk about any variable, the movement of that variables cannot be actually simply say constant over the time. So, what we say that constant means it maintains like horizontally simply. Okay. So, that is 10 10 10 like this, 20 20 20 like this. So, that is what the stagnant is all about in a kind of time series format, and in reality that is very difficult for a industry, for a individual or for a country to maintain that kind of things. Definitely there will be up and downs. Even if you maintain, you have a lots of safety measures to have this kind of maintenance, but still there are certain external factors through which this change may happen. So, that is why we have a different forms of time series understanding, starting with this secular trend, then again we will go through the other components like seasonal variations, then cyclical variations, and then irregular variations. So, now like the trends, secular trends, so the variations may be seasonal in character. So, that is again slightly in a longer intervals, but seasonal may be 3 months intervals or 4 months intervals, 6 months interval like this. So, that means here the change happening over this seasons only. For instance, let us say production of woolen clothes. So, obviously, if it is actually summers, then the trend may be constant over a time. So, the moment it will be going to winter, then obviously there will be high demand, and then by default sales of these or production of these woolen clothes will start increasing. So, again, so it will increasing. So, when the means the moment winter will start increasing its volume, then it will again reach a peak, and again the winter will start down, and then the production will be down, and again it may be maintained like the original one. So, that means this kind of change is with respect to seasonal variations. So, like each year more ice creams are sold in summer. So, that means mostly the time series data which is having variations with respect to different seasons. So, so there are certain engineering areas where so the information contents information contents are changing, or may change with respect to different point of time, or that too with kind of seasonality structures. It may be with respect to 2 months interval, 3 months interval, 4 months interval, but ultimately that does not matters. Like we have discussed earlier, the day wise variations and then the decadal variations. Now, here what is happening, day wise variation, then month seasonality means it is month wise variations. Maybe in the interval will be 2 to 3 months or 4 months like that, but the change will be happening, or ups and downs happening after a certain months only, and that too what the structure of the seasonal variation. So, likewise, we have cyclical variations, and that is mostly because of business cycle operations. That means whatever things are there in the real life scenario, it ultimately depends upon economic conditions, starting with any engineering productions and the sales forecasting or something kind of a revenue structure, whatever maybe you talk there will be a kind of change, and that change is a kind of cyclical, and it is mostly because of the operation of business cycle. If you talk about business cycles, then there are two different phases altogether. So, like this. So, if you start with up and then move into down, so that means when the movement will be up to down, so it will not actually continuously down, and that too not the case of infinite. So, it will be down, and after a particular point of time it will start increasing. Again, when it will start increasing, then it will not again continuously over the in a infinite kind of structure. Again, after a particular point of time it will start down. So, that means these ups and downs are very phenomenal in the real life scenario, and some of the variables data informations will be because of cyclical variation only. For instance, if something good environment, business environment, then the sales will be good. If the business environment is down, then sales will be down. So, that is what the kind of so that means here the information about a particular variable exclusively depends upon cyclical patterns, that to the business mostly because of business cycles. So, upswing, downswing, normal, then the the data structure will change frequently. So, that means this is the regions through which there is a variation of the data, and again every point in the data will have a slight connection to the previous data, and then again the post data. So, that is why there is some kind of linkage is there, and that is what the beauty of the time series data, because it is very consistent with time framework. So, then likewise there is another case called as irregular variations, and irregular variations are fluctuation in time series that are short in duration and erratic in nature and follow no regularity in the occurrence patterns. Means it is actually very irregular, like let us say seasonality, it is a regular, every year it will be come into this particular structure, but these are all variations happening in the time series in a very occasionally, you can say floods, earthquakes, wars, like these are these classic example, crisis. So, if it happens, then there will be very a very huge decrease or huge increase. These are all negatives, but sometimes there are good policy or something kind of good technology. So, then there will be drastic change happening. So, irregular variations means technology change will not be very frequent. So, it will be coming over the time only. So, like floods and earthquakes. So, as a result, so there will be change positive, but it in a long interval and very occasionally again. So, like floods, it will be down the structure, data structure, but again it is very occasional. It may not, depending upon the external factors. So, that means technically we are still means we are in the position to say that in the time series data how the variation is coming exactly, right. That is the way we are discussing this irregular pattern. And like this we have actually discussed some of the variations, starting with the secular trend, seasonal variations, cyclical variations, and then irregular variations. So, so these are the various regions through which the time series data behaves ups and downs over the time. It cannot be stagnant, it cannot be constant. So, there is a movement. So, these are the various factors which starting with seasonal trend, then then secular trend, seasonal variations, then the kind of cyclical variations, and then irregular variations. So, that itself justifies, means logically it justifies that yes, there are ways the data will be having ups and downs over the time, and that itself gives some kind of clue to the future predictions as per the particular engineering requirement or the kind of industry requirement. And with this we will close this lectures, and in the next lectures we will discuss about the time series models and how these data can be used to predict engineering requirement as per the availability of time series data. Thank you very much. Have a nice day.